Okay, Siril 1.4 has been released in beta just a couple weeks ago, so that means it's time for a new start to finish beginners video. But before we get started, I got a few important things that I want to talk about. First, because this is in beta as I'm recording this video, some things may change once it does come out of beta, so if you're watching it further down the road and you notice some discrepancies in the video versus what you're actually seeing, check the description. I'll leave a note about any major changes that may affect the way I'm showing you guys things in this video today. Second, this is a beginner's video, so it's intended for somebody who has never used Siril before, just like my two previous versions that I've done of this video. Every time a major release comes out, I put a beginner's video out for everybody. So because of that, we're going to keep it basic. We're not going to get into a lot of the more advanced tools, just something that you can get to a final image with. I do have a ton of videos that cover Siril. Those of you that watch the channel already know that. So once you have this workflow down, browse the rest of the videos on my channel so you can learn about those intermediate to advanced functions. As the video goes through, watch for cards like this one that'll pop up, and that'll take you to a video that describes whatever function that I'm currently talking about and give you a little bit more detail on how to use it. Because again, we're just keeping things basic here. And lastly, I've left a link to my data that I'm using in this tutorial down in the description so you guys can download it and kind of follow along if you prefer to do that. So let's get to it. My name is Rich and you're watching Deep Space Astro. Okay, so if you haven't already downloaded and installed Siril, go to Siril.org, select the operating system that you're running, download it and get it installed. I'm not going to cover installing it. It's pretty straightforward. Once you have Siril installed, then the second piece of software that we want to grab is StarNet. And we're going to use StarNet later in the workflow to remove the stars from our image, like you see right here on StarNet's page. So again, starnetastro.com. I'll leave this link in the description as well. You want to click your download button. On the download page, you just want to scroll down until you see the command line tools section. This is what we want. We don't want anything else that's on this page. They do have a standalone version. That's this graphical user interface for Windows. That will not work for our implementation within Siril. So again, command line version only. Choose your operating system. I'm on Windows, so I'm just going to download that. All right, and once the download is complete, I'm going to jump over into my downloads directory, and this is a zip file, so right click and extract all. And you'll see we now have a folder for StarNet. I'm going to double click that to open that one up, and I am going to move this out of my downloads directory into a permanent location on my hard drive. You can place it wherever you want, doesn't matter. You just need to know where you put it because we need to configure StarNet within Siril. So I'm just going to cut it out of my downloads directory, and on my C drive I have a folder that I call astrophotography, and that's where I keep utilities such as this. And I'm just going to paste it in there. So that's all you need to do for StarNet. We're ready to configure Siril. So we're going to run Siril so we can get that configuration done for StarNet. It's going to come later in our workflow, but just getting everything set up in the beginning. Once Siril opens up, come over to your burger menu and then click on Preferences. And if you come down to Miscellaneous, you'll see the section right here that says Must Point to a Valid StarNet Executable. So just click on the folder icon and browse out to where you save StarNet. So again, for me, it was on my C drive under Astrophotography. There's the StarNet folder, and there's the executable. That's what it's looking for. So select it, either double click it or click your open button, and you should see starnet++.exe. Once that's in place, click Apply, and the configuration for StarNet is complete. All right, just real quick before we continue, I just wanted to let everybody know that I have also written a guide and saved it in a PDF format that follows this workflow that I'm about to show you. The guide's available for download for free to all of my members, either here on YouTube or on Buy Me a Coffee. For the YouTube members, just go to my main YouTube page and click on the membership tab. Buy Me a Coffee members, there's a shop tab at the top of the screen. Click on that and you'll see that the guide is there and it'll be tagged as free for members. If you're not a member on YouTube or Buy Me a Coffee and you prefer not to be, that's fine. You can purchase it on Buy Me a Coffee. Just go to my Buy Me a Coffee site and visit the shop tab and you'll see it there available for purchase. I'll leave links in the description below, and also updates to the guide are always free. So let's get back to the tutorial and start talking about how to structure your working directory for Siril. So the next thing we need to talk about is what's going to be our working directory. So if I come back over and show you, I have a second SSD drive in my computer. It's my D drive, and under Sessions and then Edge HD, and we're going to be working on the Rosette Nebula today. The Rosette folder is going to be my working directory, and we need to set this in Siril before we run the script to start our stacking. So if I open up my Rosette folder, you'll see I've got 4 subfolders within it: lights, flats, darks, and biases. And you absolutely have to have these 4 folders in your working directory, named as you see them here, and each of them containing the respective files. So lights, I have all my light frames. These are the images that I took that night. Flats, I have all my flat frames, so on and so forth. Darks go in the darks, biases go in the biases. If you don't follow this step, you don't have these in place, or you have them named incorrectly, the script will fail. So again, for me, my working directory is going to be my D drive, Sessions, Edge HD, and Rosette. So that's the first thing we need to do in Siril. So we're going to come over in Siril. You can see up top, my current working directory is set to just the Sessions folder. So if I come over to the blue house button, and then I'm in Sessions, so I'm going to click on Edge HD, Rosette. There's the 4 folders we were just talking about. Click Open. Verify that your working directory is correct by looking up at the top middle of the screen. You can see the path, so that looks good. Another quick check that you can do to ensure that you are in the proper working directory is to click your Open button, because it'll open up this dialog box right in your working directory. So you can look up here, say, yep, Rosette's my working directory, and there's my 4 folders. Hit cancel, and now we're ready to run the script. So we're going to come up to our scripts menu, Siril script files, and the OSC pre-processing script. Now I'm going to start this, and then I'm going to cancel it just a few seconds afterwards, because I want to show you guys something in the console screen, and this is just for the Windows users. So I'm going to go ahead and stop the process. And if we scroll back up through the log, is this line right here. You should enable the developer mode in order to create symbolic links instead of simply copying files. Again, this is Windows only. What the script is doing currently is it's making copies of your original files during the conversion process and renaming them. You don't need to be worried about what it's doing behind the scenes, but because it's actually copying that first set of files, it's taking up additional hard drive space. If we enable developer mode as indicated here, then instead of copying those files, it'll just create shortcuts to them. So it'll minimize the amount of hard drive space that it's going to take. So to enable that, again, on Windows, just come to your start button, and you can just start typing developer and use developer features. The very first item up top is developer mode. Just turn that on. Click yes when it prompts you. So with developer mode on, now I'm going to run the script again. So scripts, Siril script files, OSC pre-processing. And depending on the amount of data that you have, the speed of your computer, this will take a few minutes. So I'm going to pause the video, and we'll be right back when it's finished. Okay, the stacking is completed, as you can see over in our console window here on the right. First thing that I want to show you guys, if we go back into our working directory, so this is where we had lights, flats, darks, and biases. We now have a process directory, and we have a masters folder, as well as our final stack, which we'll open here in a minute. So 2 additional folders I just wanted you to be aware of, and we'll talk about that at the end of this tutorial. I just want to make you aware that the script does create these 2 additional folders for now. So back over into Siril, and we're going to click our open button, and there is our file, result_4140s. The 4140 is the total acquisition time in seconds of your data. So obviously your number is going to be different. I'm going to double click it to open it, and you will be presented with a nearly, if not completely, all black screen, and this is completely normal. The data is still in a linear stage, and that's what our processing is going to do. We're going to pull that data up front so we can see it. So in order for us to do that, we need to change our display mode. Our display mode is this button down here on the bottom that says linear. As I said, where the data is still linear, so this is exactly what it looks like at this point in time. If we change our display mode from linear into auto stretch, that's the actual data in your completed stack. Now, again, this is just a display mode. If I was to save this file out as a JPEG at this point, it would be completely black. It would look just like it does in its linear state. So we have processing to do. This display mode is just so we can work on our data before we get to the stretching piece. So the first thing we need to do is crop the image, and we need to crop the image because along the edges, as each of those individual light frames were stacked together, you may see some artifacts from that stacking process. This one isn't too bad. But to make it easier to see, I found that if you come out of auto stretch and you go into histogram, this extreme histogram view will help you see those artifacts along the edge. And it's very faint in this one. This one wasn't too bad. But all we're going to do is I'm going to come up to the top left corner, hold my left mouse button down, and I'm just going to drag a selection box all the way across and then let go of the left mouse button. And you can move this around just by holding your left mouse button. You can move your whole selection around. You can also adjust the sides by grabbing the handles on either the top left or bottom. And then the same thing on the corners, right? You can drag the corners around as well. So once you have that in a position where it'll remove the stacking artifacts around the edges, we're going to right click, hit the crop menu, and then click crop. And our stacking artifacts are gone. So let's go back into an auto stretch display. And the next thing we want to work on is removing the background gradients. Now, a background gradient in an image comes from city light pollution, from the moon, any kind of external light source that is getting into your image. And you can see in this one, the top left corner looks brighter than the bottom right corner. So that's what we're talking about here, removing that gradient in the image to try to flatten that background out a little bit. So we do that with Siril's background extraction. So we're going to come up into image processing and background extraction. There are different interpolation methods. Leave it in RBF, that's the best one to use. Smoothing is the amount of smoothing as it removes the gradient for you. So once you run through this process, if you still see a little bit of a gradient, you can come back and you can make adjustments to your smoothing factor. And we'll talk about samples, spline, and grid tolerance here in just a second. But the first thing I want you to do is just click your generate button. And you can see all these little red squares. These are sample points for the background extraction tool to sample the background of your image and determine where the gradient is and how to smooth it out. And that's where the samples per line and the grid tolerance comes into play. So default samples per line is 20. If you were to count any of these rows, you would have 20 sample points. And the grid tolerance is basically how it can detect where it thinks it should be putting these samples down for you. So you can see it's mostly on the background. It stayed away from the bright areas of my image. If I was to bump this down even more and then hit generate, you can see these ones disappeared. If I went down even further and hit generate, even more of them disappear. If I went all the way over to the right, it's pretty much going to light up the whole image, getting into the nebula, which we don't want. So you can use a tolerance to help you more quickly get these sample points down, but generally the default 2 works rather well. But you do need to do some editing to these sample points because, again, we're talking about sampling the background of the image. So anywhere that you have a sample point that's on the object within your image, so the Rosette Nebula in my case, I don't want these sample points sitting on the bottom part of the nebula. So I am just going to right click to remove the ones that I don't want. And then like over here, there is some faint nebulosity coming down into the corner. So I want to clear all these too. Instead of right clicking on each individual one, I can just double click with my right mouse button and you can see it kind of expands and clears those out for me. So just kind of a little bit of a shortcut. Some of the light nebulosity is not that big of a deal to have a sample point on, but you really do want to stay off of the main part of your image, the object in your image. The other thing that you want to watch for is sample points that may have landed on large bright stars. So for example, if I had a sample point right here, that's not good. When it does the background extraction, it can cause like dark blotching because of that sample point being there. So take a quick look at your sample points and make sure none of them encompass any bright, large stars. Once you're happy with what you have laid down, then we're going to come back over to the window and we're just going to hit compute background. You can see the difference that made in the image by removing that background gradient for us. Like I said, if you still see a bit of a gradient, you can adjust your smoothing factor up here and just hit compute background again. And when you're happy with the results, just click your apply button and the gradient removal is added into the image. Now I'm going to run background extraction one more time just to talk about the add dither option right here. Some images, and I've seen it with my Canon camera, I used to shoot with a Canon M50. You get these crazy colors in the background, these waves that go through your image that look like this once you click your compute background. If that's the case, then just come in and click add dither and then click compute background again. And it should take away all those colors in the background of your image and leave you with something that's been correctly calibrated. So I just wanted to point that out. So with background extraction complete, we're ready to start color calibrating our image. But before we do that, we need to plate solve the image. And what plate solving is just identifying where in the sky this image is at, among other things. So you're going to come up into tools, astrometry, and then image plate solver. Now, there's a lot of settings in here. I'm not going to go over most of them. Default works for most cases, but the important ones are our coordinates, our rate ascension and declination, as well as our focal length and our pixel size. And for me, these values have auto-populated. It auto-populated because I shot this image with a dedicated astronomy camera that produces FITS files. And a FITS file has a FITS header. So let me show you that real quick. If I come up in the tools and then FITS header, this is all the information that is actually stored in my image. And it's actually stored in each individual light frame that you took that night as well. So if I came down to focal length, there's my focal length that we see right here in the plate solver. Scrolling down further, there's our rate ascension and declination, which are these two values up here. And then our pixel size is stored in here as well. So again, that's why all my values are populated. If you're shooting with a mirrorless camera or a DSLR, these values will not be set for you because there is a header for those type of files, but they don't store rate ascension and declination. They may or may not store focal length and pixel size. It depends. So if you are shooting with a DSLR or a mirrorless camera, you'll need to populate these fields yourself. And that's very easy to do. So this is the Rosette Nebula. So I'm just going to enter the catalog number, which is NGC 2244, into the search box and then click my find button. You'll see it located it. All you need to do is click on that object and your rate ascension and declination information will be populated based on that catalog search. Focal length, this is the focal length of your telescope, so ensure that that is correct. I was shooting with my Hyperstar on my Edge HD, which gives me a focal length of 425 millimeters, and then the pixel size of your camera. So if you don't know the pixel size of your camera, a simple Google search should turn it up for you. So for example, if I did Canon M50 pixel size, you can see it, and it came right up in the results, highlighted it for me. This is the AI, be careful, right? It's a great tool, but it's not always right. I would look down on the bottom here to make sure that it is in fact correct. So 3.72 is my pixel size. So if I was taking this image with the Canon M50, I would change this to 3.72. Again, I use a dedicated astronomy camera. Data was pulled from my FITS header that I showed you, so I'm good with that. Everything else, don't worry about it. They're more intermediate to advanced features. Just for a simple plate solve, this is all you need. So just click OK. All right, so now we'll move into color correcting the image. So we're going to come up to image processing, color calibration, and photometric color calibration. Default settings, all you have to do is click OK, and it'll color correct the image for you. I think you can see the difference. If you want to go back and forth, we have undo and redo buttons here. So if I click my undo button, watching the image, there's the before color calibration, and then I can redo it, and there's the after. Okay, so the next step is to remove the stars from the image before we start stretching the data. Now, this is optional. You don't have to do this. And this is why we downloaded and installed StarNet at the beginning of the video. Like I said, you don't have to do this. You can move forward and you can stretch your data with the stars in it. But sometimes as you're trying to stretch to pull out maybe some fainter gases around the edge, the stars will start getting blown out and they'll get rather large. There's other ways to fix them. There's different workflows for everything. But this is the approach that I always take. I remove my stars first. So we're going to come up into image processing, star processing, and then StarNet star removal. Default settings again are good, but just make sure that you have pre-stretch linear image selected as well as generate star mask, and then click execute. It'll take a few minutes. You can watch it over in the console screen. And when it's done, it'll load the starless image for you. So I'm going to once again pause the video and we'll be right back. All right, StarNet has finished. And as you can see, we have a starless image on our screen. So now we're ready to start stretching it, right? We're still in a linear state. So now comes the time when we start to stretch the data. So the first thing that we're going to do is change our display mode from auto stretch back into linear. And you can see in the bottom here, we have what are called visualization sliders. So even though we're in linear, you may have been expecting a black image, and you would be correct. It should be black. If you take your top slider and move it all the way over to the right, it'll get us back to that black that we're looking for. And that's where we want to work. If you don't do that, it's fine. When we run the stretching tools, it should bring that visualization slider back over to the right for you. If it doesn't, just keep an eye on it. Make sure you drag it back over because it'll make things difficult if you don't start in this completely linear view when you're starting to stretch your data. So let's look at the quick and dirty way of doing it, although it's not the best way. So come up in the image processing and then stretches and then histogram transformation. When I say quick and dirty, I mean you can simply hit this little cogwheel over here that says apply auto stretch algorithm. And this is pretty much the auto stretch view that we had when we change our display view down here in the bottom. So if I just click that button, it'll stretch my data to match what we saw before, and you can be done. If that looks good to you, that's fine. But this auto stretch tends to be a little too aggressive. More times than not, it will clip your shadows. So here's our histogram here, right? This is the data in our image. The left side are our shadows, and the right side are the brighter parts of the image. Sometimes it'll clip the blacks, and you can watch your clip percentage here. You can see right now it's nothing to worry about. It's 0.009. But if you see anything more than, I would say, 0.1%, it's clipping data. And when it's clipping data, that means you're losing some data. The other thing is the image is just way too bright. We can do better than this. So generally, especially if you're clipping data, and I'm not in this case, but I'm going to go through the step anyways. If you're clipping data, we want to start with a different type of stretch. So I am just going to hit reset and close, and we'll come back over into image processing, stretches, and this time we're going to use the AST sign transformation. This is very simple to use. You're just going to take your stretch factor and you're going to move the slider over to the right until you start to see the data in your image. Back it down just a little bit and then click apply. Now we'll go back to image processing, stretches once more, and then back into our histogram transformation. And up top here where it says 1 and you see the plus button, this is actually a zoom function for the histogram view. So if I zoom in, you can see now I've got more room over here on the left hand side, where previously this was slammed all the way over to the left. So now I'm in control of stretching my blacks so I don't lose any data like I would if I was going to use the auto stretch feature. So the button number 1 here will reset your zoom. And then if you notice on the bottom here, we have 3 triangles. This one on the left is for our shadows, the darker parts of our image. The one in the middle is for our midtones. And the one all the way over to the right are for the brightest parts of our image. Just leave the one on the right slid all the way over. You don't need to adjust that one. Start with your midtones, left mouse button click, and drag it over towards your histogram, and then let it go. It may look too bright like it does in my image right now, but again, if we zoom in to my histogram, and I grab my shadow slider and start moving it towards the data and bring it right up to where that curve starts, you can see the image started to get darker. I don't want to go too much further than that. If you watch your clip percentage right here, as I move the slider, you can see I'm starting to clip data as I go into the histogram. So that's what I was talking about. You don't want to start seeing that number tick up anything more than 0.1. So we can maybe take this right to there. We're still at 0, so there's no data being clipped. Still looks a little bit bright, so I can take my midtones and I can start sliding that back over to the right. Just a little bit at a time. Just watching the image, right? I don't want the background really dark. I don't want the image really bright. So it's just back and forth with the sliders to try to get it to a point where it looks correct. Let me try and move the blacks over just a little bit more if I can. If it gets really touchy like it is for me now, you can always zoom into your histogram further. You see I did clip just a little bit, but 0.013 is nothing to be concerned with. So I'm going to run with that. We're going to click apply, and now our image is stretched. So one thing I wanted to mention too is this, depending on your computer, if you have an older computer and it tends to run a little bit slow and you're doing your stretching and you're noticing it's not being very responsive, you have to wait a second or two for the results to actually display. You can help speed things up by using what's called region of interest. So if I was to use my left mouse button and just draw a selection similar to how we did when we were cropping, and then right click ROI and then click set ROI to selection, you'll be prompted that this tool does in fact support it. So that's good. Click OK. And now as I stretch the data, so let me reset my zoom. If I move my midtone slider over towards the data, you can see that it's only affecting my region of interest. So it's just focusing, it's just working on this area right here. So I can make my adjustments within my region of interest. And then when I'm happy and I click apply, these settings will be applied to the entire image. So it helps with the slower computers, larger files and such. So I just wanted to show you guys that as an option during your stretching. Once you close it, to get rid of the region of interest selection, just again, right click, hit ROI, and then clear ROI. And then a single tap of your left mouse button will take away the selection. Now we want to work on increasing the contrast and brightness of the image. So we're going to come up in the image processing, stretches again, and this time we're going to go into our curves transformation. And you can spend a lot of time in here making adjustments. It's a pretty powerful tool because again, We're seeing our histogram. This is the data that we have in there. We have the same zoom controls up top, so we can play with those. So to start adjusting the contrast and brightness, I'm going to put a point right there on the line, and I'm going to left mouse button press and just pull that down very slightly. And then I'm going to put another point over on the right side of my data and just pull that up slightly. Take a look and see what I have. If I like the adjustments, that looks good to me, and hit apply. And this is an iterative process, right? So you can keep going. You can make a further S curve, again, just by clicking closer to your shadows part of your histogram, and then putting a point in the right side and lifting that up. Like what you see, again, hit apply. You can also just put a single point right in the center of the line and pull that up as well, just so you can see the effect that it has. This will pretty much take the whole brightness of the image up. Conversely, if you pull it the other way, it'll darken the entire image. So I'm going to reset that because I'm happy with the way that looks, and then close. The other thing that you can do if you want to, or if you feel there's a need to, is you can increase or even decrease the saturation in the image. So if you come up into image processing, color saturation, and just play with your amount slider, right? So if I wanted to increase the amount of saturation globally, which means across all three channels, red, green, and blue, I could start bumping this up, and you'll see the image will start to get redder for us. You can get really crazy, right? If we go all the way over this way, it looks like somebody drew the image with a crayon. And then, like I said, you can reduce the saturation as well. If I hit the reset button, it'll take me back to where I started, and I can go the other way, and I could decrease the saturation in the image. So I'm gonna hit the reset button one more time and talk about the hue selection up here. Like I said, we're in global, so that means the entire image, all colors. If you pull the menu up, pretty self-explanatory, right? If you just want to work on the pinks and reds and oranges of the image, if you have any orange and brown, so you can be a little bit more specific, a little more precise with the colors that you're playing with. So if I was to do just the pink, red, orange, and move my slider over, you can see the orange came out more just by selecting that. So, play with your hues to get an idea of what colors are in your image and how you can increase them. So I'm going to go back into global, and actually I'm not going to increase the saturation on this image at all. I'm happy with the way that it looks. But again, if I was to bump it up, just make sure you hit apply afterwards, and then the window will close for you. All right, so now we're ready to put back in the stars that we took out earlier in the workflow. Before you do it, very important, make sure you come up and you click your save button to save all those changes that we just made. Otherwise, when we open up the next tool, the star recomposition tool, you'll lose everything that you just did. So obviously that's something that you want to have happen. So image is now saved. We're going to come up into image processing, and then star recomposition. It's going to prompt to close our current image. Click yes. And lots of settings in here as well. We're going to keep it simple again because it's a beginner's video. We're going to come over under our background stretch parameters, click on the folder underneath of it, and you can see we have two files that were created when we removed the stars, right? The star list, which is the one that we were just working on, and then there's our star mask. That's just our stars. We want our star list, right? That's our background stretch parameters. Give it a second and you'll see the star list is loaded back up in the screen for you. And then on the right hand side, we're going to hit star stretch parameters. Same thing, except this time we're going to select our star mask file. And the only thing you need to be worried about, again, just because we're keeping this a beginner's tutorial, is the stretch factor underneath your star mask. So just start moving this over. You'll see the stars being stretched back into your image. You can be as gentle or aggressive with this as you want. If we come all the way over to the right, you can see it's really overstretched the stars. If we leave it closer towards the left-hand side, you'll just see tiny pinpoints of some of the stars. It'll leave the rest of them out. So we're not stretching that brightness of those stars completely back into the image. So preference, right? Just play with the stretch values to get it to where you like it. And for me, I'm going to leave it there. All you need to do is click the apply button underneath star stretch and then close. One last thing that you may need to do is remove any green noise that may be in the image. Now, you only need to do this if you look at your image and specifically in the background sometimes if you see a slight green overcast. It's just an artifact of using a one-shot color camera. If you notice a little bit of green, it's easily removed just by coming up to image processing and then remove green noise, leave it at average neutral, and then click apply. If you're not sure, it's not going to hurt it to run it, and you don't have to run it if you don't notice the green noise. The color calibration that we did previously, most of the time will take care of any kind of a green cast in the image. But I just wanted to point it out in case when you get to this step, you still see a little bit of a green tint to the image. Use the remove green noise tool and that'll take care of it for you. So that's our final image. You can see up in the corner here, though, it says unsaved star recomposition result. That means it's not saved as a file. It's just sitting in Siril right now. So we want to save it. We're going to come over to our Save As button here, and you can call it whatever you want. It's going to save it in our working directory, which is the Rosette. So I'll just call it Rosette. Click Save. 32-bit floating point is good. Click Save. Now if you look at the file name, it shows rosette.fit. So now you have a saved fits image of all the work that you just did. You want to post it up on social media someplace, and you want to save it off as a JPEG. Same thing, come over into Save As. I'm going to leave the name Rosette, and you can either select your supported files down here in the menu, or just delete the .fit and then type JPG for JPEG. Hit Save, set your quality. The higher the quality, the larger the image is going to be. Click Save again. And then if we, again, jump over into our working directory, there's our fit file we just saved, and there's our JPEG file we just saved. So at this point, we have some cleanup that we can do, right? Files in our process folder and master folder are doing nothing but taking up drive space. Now, there are some files in the process folder that, for good reason, can be saved if you wanted to. But again, this is a beginner's video. That's more of an intermediate to advanced type stuff. So don't worry about it for now. So just to clean up, to save yourself some hard drive space, you can delete your process, your masters. You can delete your star mask and your starless. And unless you want to go back and practice again with your result file, you could actually delete that as well. And that'll get you back to your lights, flats, darks, and biases, right? Your original files, nothing has been changed in here. They were just used to create our result file. And then we have our final rosette.fit, and again, the one that we saved. So as always, I hope that's helpful for a lot of people, especially if you're just starting off with Siril. I want to take this time once again to say thank you to all my members, both on YouTube and on buymeacoffee.com. And don't forget, if you're already a member, you have free access to the quick start guide that I put together for this tutorial that we just went through. Appreciate everybody's time. We'll see you on the next one, and clear skies.